This video provides an overview of Kornucopia ML's unique data type, k_units. This new data type for MATLAB allows you to easily and naturally work with numeric data and their units, as well as other related meta information. Kornucopia ML for use with MATLAB is truly the horn of plenty. It has a large number of tools to help you analyze and automate the processing of complicated, messy, real-world nonlinear data. These tools are applicable for workflows that may include physical testing data and/or simulations. In this video, we will concentrate on the powerful and flexible k_units data type. This new data type, inspired by MATLAB's table data type, allows you to hold an array of numeric data, its units, descriptive text, and other related meta information in a single container-like variable. This is coupled to a seamless units engine provided by Kornucopia that ultimately allows for cleaner MATLAB scripts with less mistakes. Here's a typical variable of type k_units being presented with Kornucopia's variable viewer. As you can see, there is some additional descriptive information at the top, along with column names and units associated to a large array of data at the bottom. And here is an example of some typical calculations that can be done in Kornucopia. The key points are we have an organized tabular data format. Equations and commands are easy to read. Kornucopia handles all the units-related portions of the calculations, including the use of mixed units. The k_units data type works efficiently with very large data sets, and your analysis is clear and accurate. Let's take a moment to consider the traditional approach to data analysis, where you're often working with just the numeric part of your data. Here's an array that is holding values related to some materials. And here's a calculation to compute the thermal stress of constrained rods of these materials based on an applied change in temperature. Obvious questions are, what are the columns and rows representing? And what are the units for this data? And where did this data come from? And of course, what are the units of the result? Using the traditional approach of computing with just numbers leads to a workflow that is not clear and can easily lead to mistakes or misinterpretations. With the Kornucopia ML approach, we hold the data in a well-described variable. And then we can use natural and clear MATLAB syntax to calculate the stress in our constrained rod, where we are now applying units to the temperature change, and our formula is much clearer. Through the Kornucopia units engine, the calculation in MATLAB handles all the units, and it is quite easy in Kornucopia to convert variables and output into different units, ultimately resulting in a very clear overall workflow. Creating a variable using Kornucopia's k_units data type is easy and flexible. There are multiple ways to create and use them. The example on the right uses a combination of the Kornucopia function k_unit variables and MATLAB multiplication to create and use a variety of units and variables in a calculation. The example shown assesses the heating of a car's brakes and its deceleration during a stopping event. Kornucopia allows you to easily work with mixed units, and your calculation results are clear and accurate. Here's a demonstration that uses the constructor function k_units to define some tabular data that has different units in various columns. Using the MATLAB dot notation, you can easily define or modify various properties of your variables. And if you want to get at just the numeric data portion, you simply access the data property as shown here. The Kornucopia variable viewer provides a comprehensive view of any given variable that is of type k_units. In addition to displaying the primary tabular data, including any column names and units, the variable viewer also displays other meta information if it exists. In this example, the viewer is displaying an overall variable description and column comments that are present in the variable. Kornucopia ML is based on a powerful units processing engine that is much more than a simple units conversion tool. So if you enter equations like this into MATLAB, where we are defining a weight, converting it to a mass, then defining a stiffness, and finally computing a natural frequency, Kornucopia will handle all the units-related issues, returning the natural frequency result as shown. It is clear that Kornucopia works well with units, including mixed US customary and SI units in the same calculation flow. Kornucopia does more than just work with units, it helps check your calculations for units compatibility. If you were to enter an equation like this, where we have added a force, 50 newtons, to a mass defined by the variable capital M, Kornucopia will produce an error telling you that you are using incompatible units. It describes the problem, gives you guidance on what to do, and also gives you links to the help system for more guidance. The key points are Kornucopia ML is superior to a simple units converter. It has a true general-purpose unit engine that handles units of all sorts, including mixed ones, based on something called unit signatures. The software is designed to efficiently work with huge datasets and to enable flexible workflows that reduces errors and saves time. Switching our focus back to the traditional approach, we note that computing with just numbers can sometimes hide mistakes. Here's an example of calculating the natural frequency of a beam with a concentrated mass at its center. The variables for the problem are defined using just numbers, and these green lines of text are only comments for the user. The MATLAB compute engine ignores them. Thus, MATLAB is only computing with just numbers. Calculating from the inputs, MATLAB returns the natural frequency as a value just under 53, and the engineer reports a result of 52.7 Hz. Is this result correct? Can you tell? Kornucopia can. Because Kornucopia works with units, it can identify a variety of mistakes that may exist in your calculations. To demonstrate this, we repeat our analysis, but this time we apply the units to our inputs instead of having them as just comments in our script. So now the MATLAB compute engine, supported by Kornucopia ML, properly performs the calculations, including the units. In this particular case, we get an error because Kornucopia has found a problem with our equation. It has told us that around the plus sign there are incompatible units. Further assessing this equation, we see we are missing some parentheses. After including them, the calculation is completed, but the units of the result seem strange to us. So while this is valid from a units compatibility viewpoint, Kornucopia's units-related features are still helping us detect something is wrong with our analysis. After one more look at our equation, we see that L squared should have been L cubed. So now we can complete the calculation, including a few unit conversions to obtain results that we are confident in. Kornucopia ML also robustly handles thermal calculations, allowing you to naturally work with all the various measures of temperature: Kelvin, Rankine, Celsius, and Fahrenheit. Kornucopia also helps you safely deal with the affine temperature issue. Consider a temperature of 100 degrees Celsius. If this represents the temperature of boiling water, then its conversion to Fahrenheit would require an affine conversion that includes both the 9/5 multiplication factor and the 32-degree offset. In Kornucopia, this is simply achieved by including the affine on option with the convert method. If, however, the 100 degrees Celsius represented a change in temperature, often termed a delta T, then the conversion to Fahrenheit would be non-affine, meaning the 32-degree offset should not be included in the conversion. In Kornucopia, simply use the affine off option in the conversion request. This approach is cleaner and easier than you remembering the different multiplication and offset values for various temperature conversions. Using Kornucopia with thermal calculations allows you to use all forms of thermal-related units, including mixed units and the dreaded English thermal units. And if you have any equations with temperatures raised to powers, such as radiation, Kornucopia will guide you to use the proper absolute forms of temperature, either Kelvin or Rankine. Kornucopia's units library is large and modifiable. It is based on a true units engine that uses a variable's unit signature. This is much more than just a simple units conversion table. It properly tracks units compatibility in all your calculations, allowing you to comfortably use various units associated with your data, including mixed units. The library has hundreds of units predefined. It contains typical ones like meters, newtons, seconds, millimeters, pounds, force, and such, and some odd ones like slinch, furlong, fortnight, and cotton count. You can easily add or modify units in the library using simple commands like these, and it is simple to control the units of your output via unit preferences, where you can either use predefined preferences or create your own. Here's a brief video showing some of the units in the library where literally hundreds of units exist. Kornucopia ML's powerful features work naturally in MATLAB. There are more than 80 overloaded MATLAB operators and functions so that you can do math very naturally in MATLAB. All of these functions here understand the k_units data type. In addition to that, there are over 90 native Kornucopia ML functions that do a large range of common tasks related to general data analysis. Here's an example of automatically processing a text file. The file to be imported has two different regions of header text, as well as tabular data below that. Using the k_read_text function, we can easily import the text file into a tabular variable of type k_units as shown, where it is clear what the columns contain. Using the unpacked header function, it is easy to turn this section of the header into a useful variable that can then be used in calculations to turn this raw load displacement data set into a useful stress strain curve. The equations are clear and easy to read, and Kornucopia has handled all the issues of mixed units. Now that we have the data calculated in a form we need, we can clearly plot the results using these two Kornucopia functions to produce a plot that includes automatic labeling, a legend, and a title. With Kornucopia ML, you get faster data analysis with greater understanding, because you get to work with all your data, numbers, units, and text. This enables flexible and more accurate workflows, giving you and your organization greater confidence in your results. There are powerful tools to process messy and noisy data for solving important real-world problems. With efficient plotting that has automatic labeling, you can quickly and clearly communicate your results. And our real-world template examples allow you to jumpstart your solutions. This is all supported by a teaching help system that allows you to learn more and grow your value. Kornucopia ML improves the speed, precision, and effectiveness of you and your organization.